Welcome to EDU World Space.
Problem 3.131. In this problem, the radius of this circle is given 5 meter. That is the red circle that is shown here. So I am writing it as capital R, that is 5 meter, and all of these forces are on a circle of radius 4 meter. It means that all of these forces are at a distance of 4 meters. So I am writing the inner circle at which these 4 forces are acting to be small r, that is 4 meter. This black dotted circle has a radius 4 meter. Alright, so we have to find the magnitude of equivalent force and its point of application because of these 4 forces, because of these 4 weights that are acting on the system. So first of all, let us make a little effort to draw an equivalent force system, and we can draw it. So this was our z-axis, and this was x-axis, and this was y-axis. Alright, so I'm assuming here that our resultant force is acting, let's say, here. So resultant of magnitude r is acting in xz plane. Since the point of application of all of these 4 forces in actual diagram is in xz plane, so resultant will also have the point of application in xz plane. So let us assume that the coordinate, a general point for this point of application will be x, comma, its y coordinate is going to be 0 since it is in xz plane, and its z coordinate will be z. So first of all, to calculate the magnitude of r, we can balance the forces along y-axis. So if we balance the forces along y-axis, all have the same direction and all are parallel to each other, so we can directly add up them. So equivalent force comes out to be 100 plus 75 plus 125 plus 25 kilonewton. So if we solve this, this will be 200, 300, 325. So this comes out to be 325 kilonewton. So this is the magnitude of equivalent force. Now for the point of application, we can balance moments about x and z axis respectively. Since these distances, this distance will be z and this distance will be x. So if we balance moment about x axis, so in equivalent diagram, the moment will the value of the moment will be, since this is now I'm considering this here, this direction is positive, this direction is positive, so moment caused by this r, since it is in the positive quadrant of z and x, so mx will be force multiplied by perpendicular distance, and its distance is z, so this will be z. Now if we talk about the equivalent force system, so along the x-axis, if I am calculating moment, so moment because of this 25 kilonewton and 100 kilonewton is going to be 0, because these two are on the line on the axis at which we are calculating the moment. So because of 100 Newton will be 0, because of 25 Newton will be 0. Now this 75 Newton is in the positive z direction, so its moment will be plus 75 multiplied by its distance 4, and this 125 kilonewton is in negative z direction, so its moment will be minus 125 multiplied by 4. Now value of r is known here, so we can get the value of z as 75 minus 125 multiplied by 4 divided by 325. So if we calculate these values, it comes out to be minus 15 to 4 divided by 325. So its value comes out to be minus 0.615 meter. It means that its x coordinate is in negative, so we can see here that x coordinate will be negative for these two quadrants. So our resultant force will be in either this quadrant or this quadrant depending upon the value of z. So to calculate the value of z, so from here, depending upon the what we have got here, the value of z, and value of z is negative, it means that our resultant will be either in this quadrant or this quadrant, since here the z value we have calculated. Alright, now in actually the equivalent force will act in this quadrant or this quadrant, it will depend upon the value of x. If the value of x comes out to be positive, then our resultant will act in this quadrant, otherwise in this quadrant. So to calculate the value of x, we can balance moment about z axis, which will be r multiplied by x, and that is equals to, now if we are calculating moment about z axis, so because of this 75 kilonewton and 125 kilonewton will have zero moment since they lie on the z axis, so their moment contribution will be zero. Now if we talk about this 25 kilonewton, it is on positive x axis, so its moment will be 25 multiplied by 4, its perpendicular distance. And for this 100 kilonewton, it is on negative x-axis, so it will be minus 100 multiplied by 4. So if we solve this, so from here we can write that value of x to be 25 into 4 minus 100 into 4 divided by r, and the value of r was 325. So if we calculate this by using calculator, it comes out to be minus 0.923 meter. So we observe here that in both the coordinate of x and z is negative, it means that this quadrant will satisfy this condition. So our resultant will be in this quadrant at a distance x is equals to 0.923 meter and z is equals to 0.615 meter. So the coordinate of the equivalent force, coordinate of point of application of equivalent force will be, x will be minus 0.923, y will be 0 and z will be minus 0.615. So this is the final answer.